Hi students, in AI Unit-3, today I will start the another topic which name is Procedural versus Declarative Knowledge. So first I will give the basic introduction and then I will explain procedural knowledge and then declarative knowledge. Okay. We have discussed various search techniques in previous chapters. Now we would to consider a set of rules. Rules for represents. First is knowledge about relationship in the world and knowledge about how to solve problem using the content of the rules. First we can find out the knowledge. Knowledge about relationship. Objects and attributes are connected and that relationship. Now if we have some problems, then we can find out the rules how we can solve that particular problem. Okay, and we can use some knowledge for solving that particular problems. Okay, now procedural knowledge. Its basic introduction and its example is given. In GTU examination, the question asked like explain procedural versus declarative knowledge. Then you can write first procedural knowledge, then you can write declarative knowledge, or in 2 marks question the question asked like give the difference between declarative knowledge and procedural knowledge. Then you can write the difference like this. Okay, so here in the procedural knowledge, a representation in which the control information that is necessary and we can use the knowledge which is embedded in the knowledge itself. Okay, so some examples are given like computer programs, directions and recipes. This indicates specific use of implementation. We are computer students or faculties. Okay, so we know that in computer basic theory, then its practicals are given. So first we can learn basic introduction about theory and then we can perform some practical about that particular topics. Okay, now the real difference between declarative and procedural views of knowledge lies in where control information reside. Means we can find out the difference. Okay, how we can process the knowledge data and how we can declare the knowledge data and then we can control the information. Here one example is given. We can consider man in bracket Marcus. Marcus was a man and Marcus was a Caesar. So we can write man in bracket Caesar. Okay, now person in bracket Cleopatra and for all x man x to person x. Okay, so these are the basic sentence and we can take the functions of that sentence. Now we can try to answer the question. Person Y, the knowledge base justifies any of the following answers. Here we can find out who is the person Y. Here 3 basic possibilities are given. y is equal to Marcus, y is equal to Caesar, and y is equal to Cleopatra. Okay, so person possibilities are 3 from these sentences. Okay, now we get more than one value that satisfy the predicate. Predict means we can assume something. Okay, here some in example some basic functions are given, and from that function we can assume the person name. Okay, so here we can assume 3 names. Now if only one value is needed, then the answer to the question will depend on the order in which the assertions are examined during the search for a region. Okay, so here we can find out the value and we can find out the question's answer, and that question's answers are depend on the order. Which order we can find out how the response is possible. Okay, and in declarative we can find out or we can examine the questions. In case of procedural representation, they show how they will be examined. We can give the procedural representation. Okay, and then we can examine, we can find out the particular questions answer. Okay, so this is the procedural knowledge. We can use some procedure on the knowledge and we can find out the problem's solution in the procedural knowledge. Now declarative knowledge is given, a statement in which knowledge is specified but the use of which that knowledge is to be put is not given. Statement is given, so we can find out the knowledge, but here the knowledge description is not given. Okay, for example, laws, people's name, these are the facts which can stand alone, not dependent on other knowledge. Okay, person name is not dependent on the other knowledge, it is the unique. Okay, and the laws, court law, in court we can follow the laws. Okay, so they are not dependent on the other knowledge. So that are the examples of declarative knowledge. So we can use the declarative representation. We must have a program that explains what is to be done to the knowledge and how. In program we can find out the procedure which is done and the result of that particular process. For example, a set of logical assertions can be combined with a resolution theorem prover to give a complete program for solving problems. Here we can take some logical operators, okay, and then we can find out the resolution, and then we can find out the problem's solution. When our program is completed, then we can compile the program, and if our program is right, then we can show the results of that particular program. So same procedure follow on the problems. Okay, we can find out the all possible solution of that particular problem. Okay, and then we can solve the problem by using the base solution. Now the different statements are used for different reasoning, and we can prove the statements, and we can take the sentence at first and find out all the possibilities, all the paths. These paths define the execution paths, which is similar to the if then else in traditional programming. In these execution paths, we can take the possibilities. If some condition, then else some another condition. Okay, if first is true, okay, in programming you can like if then else part. Okay, so if path is not executed, then the loop is going to else path and we can get the solution. So this concept is used in declarative knowledge. Okay, if one possible is not solution, particular not solution, then we can use the another solution or another way for finding the particular solution. Okay, so logical assertions can be viewed as the procedural representation of knowledge. We can use some logical representation. Okay, so this is the theory of declarative knowledge. Now the difference is given: procedural versus declarative knowledge. Procedural knowledge have high efficiency. Declarative knowledge has high level of abstraction. Second difference, procedural knowledge has low modifiability, means if we can change some procedure, then the modification is possible in the procedural knowledge. And in declarative knowledge, good modifiability and good readability is possible. Okay, third difference is low perspective adequacy. It is better for knowledge engineers. In declarative knowledge, it is suitable for independent facts. We can use some independent facts in the declarative knowledge, and in procedural knowledge we can use dependent statements or sentences. Next difference is produces creative, reflective through and promotes critical thinking and independent decision making. We can make some independent decisions. Okay, and we can use the critical thinking, different paths, different solutions which are possible in the procedural knowledge. And in declarative knowledge, good cognitive matching, means better for domain experts and end users, and low computational efficiency. Okay, so this is the difference for procedural versus declarative knowledge. Now our second topic is logic programming. In logic programming, first the basic introduction is given, then we can take the example and reason behind the facts. Logic programming is a programming paradigm in which logical assertions are viewed as programs. Means in the logical programming we can use the programming for different logics. Okay, and we can view different logic in the programs. If you can write the calculator program, then different logics, different functions are used, like addition, subtraction, multiplication, division. Okay, so we can use the different logics for different functions. Okay, so the program for find out the calculator, it is known as logic programming. Okay, these are several logic programming systems. Prolog is one of them. Here the Prolog concept is given. In AI, you can learn the Prolog. Okay, and it is used for logic programming system. Now Prolog definition is given and its example. A Prolog program consists of several logical assertions where each is a Horn class. For equation, a class with at most one positive literal. In Prolog programming, we can find out the logical assertions. Means here one example is given. For example, P, comma P or Q, comma P to Q. Okay. So this type of example we can use the Prolog programming. In your practicals, different programs are given for Prolog. So you can perform that programs and learn the Prolog. Now the facts are represented on Horn class for two reasons. Here we can use the Horn class. Okay, and here two reasons are given. First is because of a uniform representation, a simple and efficient interpreter can be written. Here we can use the uniform representation, means we can follow the basic rules and regulations. Okay, and then we can find out the simple and efficient interpreter, and then we can write the facts. Second reason is the logic of Horn class is decidable. We can use the logic, okay, for the different classes, and we can declare the classes. Now the first two differences are from the fact that Prolog programs are actually set of Horn classes, and then we can transform that Prolog programs into Horn classes. Okay, class form I will explain in the previous video lecture. So here you can understand the Horn class. First is, if the Horn class contain no negative literal, then leave it. It has no negative literals, means our result is positive, then we can leave it. Second possibility, otherwise rewrite the Horn classes, okay, and then we can implicate, means we can rewrite that class, and then we can combine all of the negative literals, and then we can find out some single positive literals. Okay, so this is the two different forms which are used in Prolog programs. Now the procedure uses a class which originally consists of a disjunction of literals, means one of them was positive. In the class process, we can find out the positive literals, okay, and if one literals is positive, then we can remove the negative literals, and then we can transform a single implication, okay, and it is a conjunction universally quantified. Now when we apply this transformation, any variables that occur in negative literals and so now occur in antecedents, means here we can apply some transformation, okay, and we can use any variables in the negative literals, and then we can find out the quantifier. Quantifier topic is also completed. So here the variables are consequence, and then we can find out the universally quantified, okay. Now example is given. For example, the prologue class is p of x to p of x, where q of x comma y is equal to logical expressions. For these we can use the logical expression. So we can write this sentence like this: for all x there exists y q x comma y to p of x, okay. So in the basic we can write the sentence like this, and in prologue we can write the sentence like this. We can use the logical expressions to represent the classes, okay. Now the difference between the logic and prologue representation is that the prologue interpretation has a fixed control strategy, and so the assertions in the prologue program define a particular search path to answer any questions. Now we can find out the difference between logic and prologue representation, okay, and then we can fix the control strategies, okay, and we can find out any questions answered in the prologue program. But the logical assertions define only the set of answers, but not about how to choose among those answers if there is more than one. And here we can use the logical assertions, okay, and for one question answer we can choose many answers, and from that answers we can select the best answer, okay. Now we can consider the following example. First is logical representation, okay. So in logical representation, for all x, pet x and small x to apartment pet, we can know that in the apartment the pet animals permission is given, and we can know that pet permission is given and they are small. So we can write that sentence like this: Now for all x, cat x or dog x to pet x. Okay, we can select only one pet animal, either dog or either cat. And for all x, poodle x to dog x and small x, poodle, fly, fly. Okay, so if we can select the dog animal, then it is also small. We can't select the big animal. Okay, because it is the not accepted by the different peoples of that apartment. So this is the first logical representation. Now second is prologue representation. In this representation we can write the sentence like this: apartment pet x, where pet x comma small x. Okay, we can select pet animal but they are small. Now pet x, cat x, pet x to dog x to poodle x, and small x to poodle x, and poodle, fly. In maths you can write the functions like this. So here we can use this representation in the prologue. Okay, so this is the example for logical representation and prologue representation. Now I will revise the today video lecture topics. Today I will start the next topics of unit number 3. Our unit 3 is knowledge representation. In this unit 3 previous video lecture I will complete the resolution topic, its basic definition, its algorithms are completed. Now today I will start the procedural versus declarative knowledge. First I will give the basic introduction and then I will start the procedural knowledge. Okay, its basic definition and its example is given. Now next is declarative knowledge. Its basic introduction and example is completed. Then I will explain the difference between procedural knowledge and declarative knowledge. In your GTU examination, the question in 7 marks ask like give the difference between procedural and declarative knowledge, or explain procedural versus declarative knowledge in detail. Then you can write this theory. Second topic, logic programming. First I will explain the basic logic programming, and the prologue programming is present in the logic programming. Two different reasons are given. Then the example is given for prologue classes. Okay, and the difference is given between logical representation and prologue representation. Its basic definition is given, and we can learn the difference by using the example. Here we can take the example of pet, and we can select the small pet in the apartment. So in logical representation we can represent the knowledge like this, and in prologue representation we can represent the knowledge like this. So by using this example you can learn logical representation and prologue representation. Okay, now in the next lecture I will start the topic forward versus backward reasoning. Okay, thank you.